Hello, everybody, and welcome to our almost last lesson. This This is called 12-4, and we are inside circles. Now, you remember from last week, if you are on a circle, you're all so tuck this in the back of your mind. You're always half of the arc that you open up to. So remember that was 12-3. Okay, so remember that rule. The new rule is if you're inside somewhere, and this is pretty cool, if you're inside somewhere anywhere like this, you notice that this angle X, I did not put it anywhere specifically towards the center. It doesn't really matter. But the cool thing is about this one, and if we were in class, we'd investigate this and all sorts of stuff. But the cool thing about this one is you take the average of these two arcs. Sorry, my hand isn't going the right way there. So all you got to do is you take arc AB and you add arc CD and you divide it by 2. That's it. So if this is like 120 and this one was like 60, you'd add them together, which is 180. You divide it by 2, which is 90, and that actually looks like it's kind of 90. We'll get to some number examples in a second. Okay, so here's a couple. So you're like, oh look, all right, slice, and we'll do one from the center in a second just so you can see. Slice. You're like, ooh, how big is this angle right there? Well, this one is like 50. And this one out here, see, I'm sort of imagining how big it is like 80. You're like, now you could think in your mind, I know what halfway between 50 and 80 is. It's 30 apart, so they're 15, it's 65. Or you say, I can't do that. So I'm just gonna go add my 80 and 50 together and divide by 2, 130 divided by 2, 65 degrees. Now look at what I could do too. I could find any of these, right? Because the vertical angles, I could find the linear pair right here. In fact, a couple different things to say here. If they give you something here, let's say that goes to the center, and another one that goes like over here, so it doesn't really matter, right? It doesn't really matter. But the cool thing is, we could go like, hey, this is 90 over here, and this is like 50, and you're like, well, this doesn't make any sense. And then I say, oh, find X over here. If I can't do this, that doesn't work with the rule, because the rule says I have to have either of these two. Well, if you think about this, there's a couple things we could do. Since that's a diameter, that's 130, or since that's a diameter, that's 90. So you could put your 90 over here, and 50 plus 90 is 140, divided by 2 is 70. So now we know that's 110. Or 50 from 180 is 130, and 130 plus 90 is 220, divided by 2 is 110. So regardless, now you might want to say, oh, I want to make sure that actually works to the center. Well, of course it does. If you're actually going to the center, remember central angles, if this is like 100, so is that, and there's 100, so is that. So this angle in the middle is halfway between 100 and 100, and halfway between 100 and 100 is 100. Doesn't really make sense, but that works. Okay, so if it's inside anywhere, just add them together, divide by 2. Add them together, divide by 2. The most complicated for the beginning that will be is they might give you a picture something like this and say, hey, that's 70. Hey, that's like 100. Find X over here. Well, no biggie. You can still just find out what these two add up to. 170 divided by 2 is 85. And then, sorry, my picture's a little bit off. We'll call this 120 to make it a little bit. 190. Oh, look, that's 95. And then you just subtract from 180 to get 85 there, which is fine. Okay, so that's pretty cool. The last one is kind of funky. It's an outside angle. Now, tomorrow, or Wednesday, I mean, we're going to do some cool things with line segment lengths, like this has this long and this long and this long and this long. What these are is angles. How big is the angle inside? But this one is, what if the angle is outside? And there's a few different ways this can happen. It can look like this with a secant and a secant. It can look like this with a tangent and a secant. Or it can be really cool with a tangent and a tangent. And we're looking for X all 3 times. Now these are all outside, you see, outside. And the rule for outside is super cool. The rule for outside is the same for all three cases. It's you take the big arc that opens up to, and you take the little arc that opens up to, and you subtract them. See, here you add them and divide by 2. Here you subtract them and divide by 2. So I'll just jump into numbers here. So whatever this bit, well, yeah, okay, so big arc minus little arc divide by 2. So if this is like 100, and this guy is like 50, 100 minus 50, the big arc it opens to, and the small arc, see how this angle is creating two arcs, the big one and the small one. The big one is 100, the small one is 50. Subtract them, divided by 2 is 25. And that's why this angle right here is 25 degrees, and it kind of looks cute and little. This guy, let's say I've got like, this is like 170 or something like 179. Okay, big. But you're like, where's the small angle? Well, the small angle, now they could give you this part here and make you subtract, or the small angle is just this part. So let's say that's like 80. So then you just have to go 170. You look to see the big angle is 179, the small angle is 80. 179 minus 80 is 99. 99 divided by 2 is 49.5, and that's why this angle right here would be 49.5 degrees, which is pretty cool. Now the interesting thing is, there's all sorts of things we could do with this. They could go backwards, which is something I forgot to mention over here, and I'll do this in a second. Like if you've got an angle in here, and they're like, hey, this is 80, hey, this is 70, what's that? Well, this is supposed to be halfway between here and here, or this plus 70 divided by 2 is 80. But you notice that 110 is halfway between these, 65 is halfway between these, so this number is halfway between 70 and 90, and then you just look and see, is 160 divided by 2 the right answer? Yep. Okay, that's a little side thought. They could do the same thing here, giving you the little one, finding the big one out there. This guy, the quandary about this guy is we don't know outer or inner. So let's say they just make this being like, I don't know, like 200. Well, if that's 200, then what's left for the whole circle? 160. Well, 200 minus 160, 200 minus 160 is 40. And 40 divided by 2, the picture doesn't look right. The scale doesn't look right. But big arc minus little arc divided by 2, same deal, always. Big arc minus little arc divided by 2. Pretty darn cool. So there's one more finale here. There's all sorts of things they could do here. They could say, hey, here's an outside here, and then here's like something weird like this. Okay? And they say, this is 50. This is like 20. And this guy here is like 100. Okay, let's see if we can do this. And they want to find X. Okay. I'm going to need some more here. Okay. Well, first of all, maybe they'll do something like this. This is the same as this. Ooh, that's going to be cool. Okay, watch this. Hey, look, 20 is outside, and it went to here. So something minus 50 was 40, right? Something minus 50 was 40 to divide by 2 to get 20. So that had to be 90. All right, so there's 190, but if that's 50, so is that. And now we got 290. 100, 200, 90. 290 from 360 is 70. And now, what's halfway between 70 and 100 is 170 divided by 2 is 85. And that picture looks terrible. That's so off scale. Sorry about that. So just pretend that worked really nicely. But this would be like whatever it was in between. These would be